What would happen if we established a Silicon Valley in Algeria? What information or possessions are necessary? Before we go back to Algeria, let's first learn how the United States of America's Silicon Valley evolved to prominence. The Silicon Valley in the United States of America started to rise due to a combination of factors, including proximity to top universities, innovative entrepreneurs, and government support. From humble beginnings to tech hub, Silicon Valley's journey to becoming a global tech hub is a fascinating story of innovation, collaboration, and a bit of luck. Here's a breakdown. Early days 1860s, 1930s, fertile ground, the Santa Clara Valley, where Silicon Valley is located, offered fertile land for agriculture, attracting early settlers. From farms to innovation, in the late 1800s, Stanford University was established, attracting talented minds and fostering a spirit of innovation. Radio revolution. Early 20th century saw the rise of radio technology, with companies like Frederick Sutro's Federal Telegraph Company setting up shop. Tech incubator. Stanford professors like Frederick Terman actively encouraged students to pursue entrepreneurship, laying the groundwork for future startups. The post-war boom 1940s, 1970s, government funding, World War II spurred advancements in electronics and communication technologies. Government funding for research at universities like Stanford continued to fuel innovation. Birth of tech giants. The invention of the transistor and Bell Labs in 1947 marked a turning point. Companies like Fairchild Semiconductor, founded by former Shockley Semiconductor employees, emerge as pioneers in the integrated circuit IC industry. The rise of HP. Hewlett-Packard HP, founded in a Palo Alto garage in 1939, became a major player in electronics manufacturing. The microelectronics revolution 1970s, 1990s, the silicon in Silicon Valley, the development of the silicon chip, a key component of ICs, became synonymous with the region's focus on microelectronics. Personal computers take off. The invention of the personal computer PC by companies like Apple and Commodore International in the 1970s further fueled the tech boom. Venture capital emerges. Venture capital firms specializing in funding technology startups began to flourish, providing crucial financial backing for new ventures. The digital age and beyond. 1990s present, the internet revolution, the rise of the internet in the 1990s, along with companies like Netscape and Yahoo, propelled Silicon Valley to global prominence. The dot-com bust and beyond. The dot-com bubble burst in the early 2000s, but the region rebounded with the rise of social media giants like Facebook and Google. Mobile revolution. The widespread adoption of smartphones and mobile technologies further fueled innovation, with companies like Apple iPhone and Android leading the charge. Diversification and innovation. Today, Silicon Valley encompasses a wide range of technology sectors, from artificial intelligence and clean technology to biotechnology and social media. What is a chipset? In the context of electronics manufacturing, a chipset refers to a complete set of electronic components needed to build a specific electronic device, like a computer or smartphone. It includes integrated circuits ICs. These are the brains of the device, containing millions of transistors and other electronic components on a single chip. Discrete components. These are individual electronic components like resistors, capacitors, and transistors that are not part of an IC. Passive components. These components don't amplify signals but control them, like resistors, capacitors, and inductors. Other components. This can include connectors, displays, batteries, and other parts depending on the device. Building a chipset in Silicon Valley. Silicon Valley has a complex ecosystem that facilitates the development and production of these chipsets. Here's a simplified breakdown. Design and development. Engineers design the device and its components using specialized software and tools. Fabrication. Foundries, often located in Asia, manufacture the ICs based on the design specifications. Assembly. Electronic components are assembled onto a printed circuit board (PCB) in factories located globally, including some in Silicon Valley. Testing and packaging. The completed devices undergo rigorous testing to ensure functionality and quality. Distribution. Finished devices are shipped to distributors and retailers worldwide. It's important to note that Silicon Valley may not be the sole location for each stage of the process. However, it plays a crucial role in design, development, and some aspects of manufacturing, attracting a talented workforce and fostering a culture of innovation. Silicon Valley today, Silicon Valley continues to be a global center for technological innovation with a focus on areas like artificial intelligence, AI, machine learning, ML, social media, robotics, biotech, and healthcare technology. What is a chipset? In the context of computer hardware, a chipset, also chipset, refers to a set of integrated circuits ICs that work together to manage the flow of data within a computer system. The two main components of a chipset are North Bridge Memory Controller Hub, responsible for communication between the CPU, main memory RAM, and graphics card. South Bridge Input-Output Controller Hub manages communication with slower peripherals like hard drives, USB ports, and network cards. Building a chipset in Silicon Valley. Silicon Valley's ecosystem played a vital role in developing and manufacturing chipsets. Semiconductor companies like Intel and AMD design and manufacture the individual ICs that make up a chipset. Foundries, these companies specialize in the physical fabrication of ICs based on designs provided by other companies. TSMC, a major foundry, is based in Taiwan. Collaboration. Chipset development often involves collaboration between companies that design the chips, those that manufacture them, and those that assemble them into finished products. While Silicon Valley doesn't solely manufacture chips due to the globalized nature of the industry, its design expertise and entrepreneurial spirit have been instrumental in the advancement of chipset technology. Building a chipset. Technical needs, human resources, and equipment. Developing a modern chipset is a complex undertaking that requires a confluence of technical expertise, skilled personnel, and specialized equipment. Here's a breakdown of the key elements: technical needs, chip design expertise, designing the individual integrated circuits ICs that make up the North Bridge and South Bridge requires advanced knowledge of computer architecture, logic design, and digital electronics. Tools like hardware description languages, HDLs like Verilog or VHDL, are used to describe the chip's functionality. Manufacturing expertise, understanding the intricate processes involved in IC fabrication, including photolithography, etching, and deposition, is crucial. Knowledge of semiconductor physics and materials science is also important. System-level integration, ensuring all the ICs within the chipset work together seamlessly, requires expertise in system-on-chip SoC design and verification methodologies. Software development, firmware and drivers are needed to enable communication between the chipset and various components. Knowledge of operating systems and device drivers is essential. Testing and verification. Rigorous testing is necessary to ensure the chipset functions correctly and meets performance specifications. This involves developing test plans, writing test benches, and using specialized testing equipment. Human resources, chip design engineers. These individuals translate the overall chipset concept into detailed designs for individual ICs, utilizing HDLs and simulation tools. Digital design engineers. They specialize in designing the logic circuits that make up the ICs, ensuring functionality and performance. Verification engineers, focused on verifying the chip designs for errors and ensuring they meet desired specifications. Layout engineers. They translate the logical design into a physical layout on a silicon wafer, considering factors like routing and power distribution. Manufacturing engineers. These specialists oversee the fabrication process in foundries, ensuring high yields and quality control. Software engineers develop firmware and drivers that enable communication between the chipset and the system. Test engineers design and execute test plans to verify the functionality and performance of the chipset. Project managers lead and coordinate the efforts of various teams, ensuring deadlines are met and resources are allocated effectively. Equipment, computer-aided design CAD tools, specialized software for designing and simulating the ICs at the schematic and layout levels. Electronic design automation EDA tools, software used for layout verification, design rule checking DRC, and timing analysis. Fabrication equipment. Foundries utilize highly specialized equipment for photolithography, etching, deposition, and other processes required to manufacture ICs on silicon wafers. Testing equipment. Automated test equipment aid is used to perform electrical testing of individual ICs and the complete chipset. Other specialized test equipment may be needed for specific functionalities. Building a competitive chipset requires a team with a diverse range of skills working in conjunction with advanced software tools and specialized equipment. Building a competitive chipset from scratch in Algeria would be an extremely challenging feat due to the immense technical expertise, resources, and infrastructure required. However, here's a breakdown of the hurdles and potential approaches. Challenges. Technical expertise. Building a modern chipset requires a deep pool of experienced engineers across various disciplines: chip design, verification, layout, manufacturing, etc. This talent pool might be limited in Algeria. Manufacturing infrastructure. The specialized equipment and facilities needed for IC fabrication foundries are expensive and complex. Setting up such a foundry in Algeria would require significant investment and technological know-how. Software development. Firmware and driver development necessitate a strong foundation in operating systems and embedded systems programming. Building this capability would take time and resources. Testing and verification. Rigorous testing infrastructure and expertise are crucial for ensuring chipset functionality and performance. Acquiring this capability would be a significant hurdle. Potential approaches. Start with design and simulation. Algeria could focus on building expertise in chip design and simulation using commercially available computer-aided design CAD and electronic design automation EDA tools. This could involve collaborations with universities and international companies. Focus on specific applications. Instead of aiming for general-purpose chipsets, consider specializing in niche applications. This could involve designing application-specific integrated circuits ASICs for specific needs within Algeria, for example, telecommunications, embedded systems. Partner with foundries. Partner with established foundries like TSMC for chip manufacturing. This would leverage their expertise and infrastructure, while Algeria focuses on design capabilities. Government support and investment. Significant government support and investment would be necessary to attract talent, establish research facilities, and foster collaboration with international partners. Building a sustainable ecosystem. Developing a robust chipset industry requires a long-term vision and a multi-pronged approach. Education and training. Invest in engineering education programs focused on microelectronics, computer architecture, and embedded systems. Research and development. Establish research centers focused on chip design and verification to cultivate domestic expertise. Technology transfer and collaboration. Encourage partnerships with international companies to transfer knowledge and technology. Since American technical cooperation with Algeria will be impossible because most technology companies have Jewish capital, and we know for certain that the Jewish lobby is the one who controls the American sovereign decision. The main direction for technology transfer will be Shenzhen, Silicon Valley of China. Shenzhen was known among Thai people as the gate to mainland China from Hong Kong and a popular shopping place for B-grade products. However, nowadays, whoever visits Shenzhen will be thrilled with the scene of a modern big city that is heading towards becoming a high-tech city. This article will introduce readers to Shenzhen in the 21st century, which is even bestowed with the nickname Silicon Valley of China. From a fishing village to a big city going back 40 years, Shenzhen was just a small city near the shoreline. It was a border between mainland China and Hong Kong. But when President Deng Xiaoping, a visionary leader who practiced liberal market to improve the economy in China and the man who came up with the quote, "It doesn't matter whether a cat is black or white, as long as it catches mice. It's a good cat," opened the southern coastal city, he turned it into the Special Economic Zone in 1979 to prepare for foreign investment. Among the first for special economic zones, namely Shenzhen, Zhuhai, Shantou, and Xiamen, Shenzhen is located on the Pearl River Delta. It has developed leaps and bounds from an agricultural city, a fishing village with a population of less than 30,000 people, into the world's leading technological city with more than 13 million people. For phases to becoming a high-end producer from 1979 up to the present, Shenzhen divided its development into 4 stages, which are Phase 1, 1979 to 1992. This phase focused mainly on using manpower for development. As one of the special economic zones, many businesses from Hong Kong invested in Shenzhen, holding it as a fort for production, starting with basic industrial production and later on the electronic and information industry. This made Shenzhen a part of the world's manufacturing chain and paved the way for innovative technology and high-end technological products. As there were transnational investments, there was a surge of workers from other regions of the country entering Shenzhen, and it also caused Shenzhen to expand rapidly. There were residential developments and various facilities such as ports, power plants, roads, communication, etc. Phase to 1992 to 2002. In this decade, Shenzhen had become a business city and there were more business owners, which was the result of the socialist market economy and financial innovation. At the same time, there was a change in the structure of the electronic industry around the world. All these resulted in investment and technology from big international companies, upgrading Shenzhen's manufacturing industry from focusing on using manpower to capital and high technology such as communication devices. In the world's manufacturing aspect, Shenzhen developed from lower to lower medium, and in this phase, there was growth in the high-tech industry, logistics, and finance by local entrepreneurs as well. Phase 3, 2003 to 2012. Shenzhen had made a significant change when the whole of China changed its economic system into a socialist market economy. As a result, Shenzhen did not have any advantage from being the special economic zone anymore. Besides, the city was faced with a lack of resources like land, energy, and water from the increasing population. Therefore, Shenzhen felt a need to establish new strength by promoting innovation. In the production aspect, there was a promotion of strategic industries such as biotechnology, the internet, new energy, new generation IT, etc. This pushed Shenzhen to have its place in the world's lower-medium production chain. And during Phase 4, 2013 to 2018, in these recent years, Shenzhen had successfully entered the developing stages that were driven by innovation and risen to the top of the world's manufacturing chain. With the effect of the policy to promote systematic innovative technology, Shenzhen was able to have an ecosystem, capital, and talents. Also, together with the basic structure, conducive environment for innovative development, growth of startups, and budget, Shenzhen was able to establish new innovative manufacturing that was able to attract resources from the global stage. This can be seen from 2012 to 2017, when the number of high-tech products increased 3 to 9 times and grew 12.2% yearly from 413 billion yuan to 735 billion yuan. This accounted for 32 to 8% of the GDP. Moreover, more than 2,000 companies that are located in Shenzhen have invested in more than 120 countries in every region globally. This includes famous brands like Huawei, ZTE, CIMC, and BYD that are leaders in technological innovation and have expanded their business and production all over the world, becoming a high-technology city in the east from the fishing village in the past, with a consistent policy that promotes technology like AI 2023 policy. Shenzhen of today is being referred to as Silicon Valley of China because it is the home to leading Chinese tech company like Huawei, the big producer of network hardware and communicating devices, Tencent, a social platform, WeChat, QQ, BYD, the manufacturer of electronic cars, BGI, bioscience researcher, DJI, the drone and aerial technology, as well as foreign tech company like Sensitime, AI business from Hong Kong. Lately, Tencent has a mega project plan to build Net City, the future city, on an area of more than 2 million meters square that is going to be where its research and development center is, and it will also be a residential area. The special part of this project would be that it is a city that urban lifestyle and nature will be blended together with the emphasis on the green area, bicycle lane, park, and there will be no usage of cars that all will be connected to public transport. Nevertheless, many analysts think that Shenzhen will gradually gain more importance with its readiness in both software and hardware. This differs from Silicon Valley in the USA, where their only forte is software. Also, before this, the Chinese government had announced the trial of using digital yuan money, and Shenzhen is one of the first for trial cities to use digital yuan, as well as the world's first city to try 5G. Now, all eyes are on Shenzhen, a city of technology in the East that has risen to become one of the global innovation centers, making made-in-China products not so simple anymore. Conclusion: building a competitive chipset industry from scratch in Algeria is a challenging but achievable goal in the long term. It requires a strategic plan, significant investment, and a collaborative effort that leverages domestic talent, international partnerships, and a focus on specific applications. While the initial stages might involve design and simulation, a long-term vision should encompass the entire chipset development cycle.